Hello, good afternoon, everyone. Uh, Last time we did theorem 8, the straight line drawn through the midpoint of one side of the triangle and parallel to other side bisect the third side. Now here, theorem 9, converse of theorem 8, a line segment joining the midpoints of any two sides of triangle is parallel to third side and is equal to the half of it in length. Here, in converse of theorem 8, in theorem 9, statement is a line segment joining the midpoint of midpoints of any two sides of a triangle is parallel and half of the third side. A line segment joining the midpoint of any two sides of a triangle is parallel and half of the third side. Now, let's take a triangle. Let's take a triangle here. Triangle ABC. Suppose this is a triangle ABC. Let it be A and let it be B. Let it be C. Triangle ABC. Now, suppose this is the midpoint of AB, D, and this side, this is the midpoint of ACE. D is the midpoint of AB, and E is the midpoint of AC. Uh, in triangle ABC, D and E are the midpoints of a midpoint of AB and AC respectively. Here, D is the midpoint of AB, E is the midpoint of AC, and D and E are joined. D and E, can D, E is joined. In triangle ABC, D and E are the midpoints where ADDE is joined. Here we have to prove that there BDE is parallel to BC and DE is equals to half of BC. DE is equals to half of BC. Now we have to construct a line. Let's construct a line CF which is parallel to BD. CF parallel to BD is drawn and DE is produced to F. Here CF parallel to BD. Let's construct CF parallel to BD and let's produce this DE up to F. Let it be F here. Let's make this line broken line. Okay, let's make it broken line. Proof part. For that we will make one table here. Remember statements. This side we write reason. Now statement and reason. Here A, B, C is a triangle. B is the midpoint of AB. D is the midpoint of AB. E is the midpoint of AC. Now in construction we construct here BD is parallel to EF. Okay, this line AB is parallel to CF. It means now these two triangle, we have two triangle, angle ADE and CEF. Here we can write this angle and this angle are equal, vertically opposite angle. Since E is the midpoint, this AE and EC are equal, and this angle A and angle C are equal by alternate angle, and we can prove they are congruent. So let's prove these two triangles are congruent. In triangle ADC and CEF. In triangle ADC, we have two triangles here. One is ADC, another is CEF. ADC and CEF. Now let's prove these two triangles are congruent. So we can use angle side angle. Okay, angle side angle. First of all, we can use here. Sorry, ADE is a triangle here, not ADC. ADE and CEF. Angle AED is equals to CEF. CEF. This is angle being alternate angle. Sorry, vertically opposite angle. Vertically opposite angle. Similarly, we can write AE and CE are equal. AE and CE are equal because E is the midpoint of AC. E is the midpoint of AC. E is the midpoint of AC. That is why AE and CE are equal. Similarly, angle A and angle C. Angle DAE is equals to ECF. Angle ECF. This is angle. Reason is alternate angle. Now, from this three angle side angle, we can write ADE is triangle ADE is congruent to triangle CEF. Triangle CEF by angle side angle axiom. Okay, triangle ADE is congruent to triangle CEF. Triangle ADE is triangle CEF. Now, after proving them, we can write, look here, angle E is opposite sides, angle is opposite sides is AD, angle is opposite side is CF. That is why CF and AD are equal. Here, now we can write AD and CF are equal. AD and CF are equal because corresponding side of congruent triangle are equal. Corresponding sides of congruent triangles are equal. AD and CF are equal here. Here it is joined. Now in fourth number, AD and CF are equal. Now AD and BD are equal here. We can write AD and BD are equal because D is the midpoint of AB. Because D is the midpoint of AB. Now this in third also CF is AD, BD is also AD. That is why we can write BD and CF are equal. BD and CF are equal. 3 and 4. From 3 and 4, this both are AD, that is why CF and BD are equal. This CF and BD are parallel and equal. Now here CD and uh, CF, sorry, BD and CF are equal and parallel from given from construction. Okay, here we have constructed BD is parallel to CF by construction. Now, since these two are parallel and equal, BD and CF are parallel and equal, we can write DF and BC are also parallel and equal. DF and BC are equal also and parallel. BC parallel to DF parallel to BC. Reason is Uh, if two lines join parallel and equal side, they are also parallel and equal. DF and BC join equal and parallel lines because this BD and CF are equal and parallel. That is why the lines joining them are also most them are also equal and parallel. Here BD and CF are equal and parallel. That is why DF and BC must be equal and parallel. Now from here we can write DE and BC. DE and BC are parallel. Look here, right? If DF is parallel to BC, then DE obviously parallel to BC. DE is the part of DE is the part of DF and DF is parallel to BC. If DF is parallel to BC, the line segment from DF is also parallel to BC. First part is finished. Now we have to prove half. We have to prove half. Now we can write DE and EF are equal. DE and EF are equal. Same as reason from first, sorry, in three corresponding sides of congruent triangle. Here, DE and EF both are corresponding side of congruent triangle because angle A and angle C are equal. Angle A co-opposite DE, angle C co-opposite EF. So corresponding sides of congruent triangles are equal. If is it so, DE and EF are equal, then DE is half of DF. From statement 9, DE is half, DE is equals to EF. That is why we can write DE is half of DF. From statement 9. From statement 9, we can write DE is half of DF because DE and EF are equal. DE and EF are equal, which means E is the midpoint of DF. That is why DE is half of DF. DE is half of DF. Now the value of DF is BC, so we can write here DE is half of BC because DF is equals to BC, because uh, from statement 7 DF is equals to BC. From statement 7 DF is equals to BC and 10. From 7 and 10 we can write this DF and BC are equal, so in the place of DF we can write BC. So DF is half of BC. That is what we have to prove. Here we have to prove DF is parallel to BC and half. Here triangle ABC is given. D is the midpoint of AB. E is the midpoint of AC. Now we have to prove this DE is parallel to BC and DE is half of BC. The line segment joining midpoint of two sides of the triangle is parallel to third side and half of the third side. For that, we construct a line segment CF which is parallel to this BD, and we produce this DE up to F. DE is produced up to F. Now we can get here to triangle ADE and CEF. ADE and CEF. Now let's prove they are congruent. This angle E and this angle E are equal because vertically opposite angles are equal. And AE and EC are also equal because E is the midpoint of AC, and then angle A and angle C are equal because these two lines are parallel. So alternate angles in parallel lines are equal. After proving they are congruent, we can write CF and AD are equal. CF and AD are equal. Similarly, AD is equal to BD. So this BD and CF are equal and parallel too. After proving them are parallel and equal, we can also write these two lines also parallel and equal. DF and BC are also parallel and equal. If two lines are parallel equal, then joining them are also parallel and equal. Then DE is parallel to BC, we can write. Since DF is parallel to BC, DE is also parallel to BC. Now, this DE and EF are also equal from that congruent triangle. So DE is half of DF, DE is half of DF, and DF is equals to BC we have done here. DF is equal to BC we have done here. So in the place of DF, we can write BC. So from this we can write uh, the line DE is parallel to third side. Okay, line joining midpoint of two sides of a triangle is parallel to third side and half of the third side. Now you can do same questions again. Okay,